this is GATE Computer Science 2014 question on recurrence relation. So let's see. We will see multiple ways to solve this question. So let's start. So the question is saying that a pennant, okay, this new word is defined. A pennant is a sequence of numbers, each number being 1 or 2. N-pennant means a sequence of numbers with summation equal to n. For example, this is a 4 pennant because the summation equal to 4. Okay. Next, the set of all 1 pennant, that is only 1, because remember you can only use 1 comma 2. Okay, very simple. Sequence of 1 comma 2, sequence of 1 comma 2, you can only use 1 comma 2. N-pennant means summation must be equal to n. Okay, so for example, the set of all 2 pennants, that is, this is a 2 pennant and this is a 2 pennant. Similarly, the set of all 3 pennants, this is a 3 pennant, summation equal to 3, summation equal to 3, summation equal to 3. And the question is saying that order matters, because you can see this is not same as this. Okay, the summation equal to 3, here 1 comma 2, this is a 3 pennant, this is a 3 pennant, and similarly this 2 comma 1, this is also a 3 pennant, and they are different, so order matters. The question is asking the number of 10 pennants. Okay, so this is a very simple question. Let's solve it. First of all, you understand this question, then you solve this question. First of all, the question is saying that what are the 3 pennants? What are the 3 pennants? Okay, so let's see what are the 3 pennants. 3 pennants means you can only use 1 comma 2, sequence of 1 comma 2 where summation equal to 3. Remember this point. 3 pennant, what is that? That is sequence of 1 comma 2 where summation equal to 3. And I can say what is n-pennant? What is n-pennant? N-pennant is sequence. In a sequence, order matters. Remember, in a sequence, order matters. This is given in the question that order matters. So this is a sequence of 1 comma 2. You can only use 1 comma 2. This is a sequence of 1 comma 2 such that summation equal to 3. Okay, such that summation is equal to n. Summation is equal to n. Very simple. So what is 3 pennant? For example, you can see you can only use 1 comma 2, sequence of 1 comma 2 where summation equal to 3. So I can say that this 2 comma 1, this is a pennant. Similarly, 1 comma 2, this is a pennant. And similarly 1 comma 1 comma 1, this is a pennant. You can only use 1 comma 2. Remember, you cannot use this because you cannot use 3. Okay, very simple. Okay, remember this point. You can only use 1 comma 2, sequence of 1 comma 2 where summation equal to n. This is n-pennant. Okay, in the sequence, order matters. This is given in the question that 1 comma 2 is different from 2 comma 1. Okay, now let's see. The question is asking the number of 10 pennants. So before that, let's find out number of 5 pennants or maybe 4 pennants. Let's see. Let's find out number of 4 pennants. Okay, so what is the number of 4 pennants? So let's see the method number 1. Okay, we will find the number of 4 pennants, but okay, to find this, let's see method number 1. What is the method number 1? See, method number 1 is very simple. You don't have to do much. You know that 4 pennant means sequence of 1 comma 2 where summation will be equal to 4. So what you can do, you can create cases. You can create cases. Cases you can create. For example, you can create this case that you will use 4 times 1 means you will not use 2. Okay, remember you can use 1 comma 2, and case 1 means you will not use 2. You will not use 2. Okay, next, what is case 2? What is case 2? Case 2 means you will use 1, you will use 2. Okay, you will use 2. So you can notice if you use 1 times 2, okay, here you are not using 2. Or I can say number of 2s that we are using, that is 0. Okay, here we are not using any 2. Here we are using 1, 2. This 2 we are using. Okay, you can see the summation equal to 4. And what is the case number? What is the case number 3? We can use 2, 2. Okay, we can use 2, 2. Agree? Yes or no? Now you tell me one thing. Here, how many ways? What is the number of ways here? If you do not use any 2, if you do not use any 2, all are 1, then only one way. So what you can do, you can create only 1 pennant. Okay, you can only create 1 4 pennant you can create. Okay, so the number of 4 pennants, or I can say number of ways means the number of 4 pennants. How many 4 pennants are there? So the number of 4 pennants. So you tell me here how many 4 pennants you can create. You can create any permutation of these because the order matters. Yes or no? You can create any permutation of these. 1, 1, 2. You can create any permutation of these. So that is very simple. 3 factorial divided by 2 factorial. Okay, this is very simple to that. For example, if I ask you how many permutations of AAB, what will be the answer? For this, how many permutations will be there? How many permutations you can create for AAB? That will be 3 factorial divided by 2 factorial. We already know. So similarly here, how many permutations you can create? That will be 3 factorial divided by 2 factorial. Okay, next, what is the answer for this? How many permutations you can create? 2 factorial divided by 2 factorial. That will be 2 factorial divided by 2 factorial. For example, if I ask you for this BB, how many permutations you can create? How many permutations you can create? So that will be 2 factorial divided by 2 factorial, because they are same. So 2 factorial. Okay, so very simple. Now you can see here answer will be here 1, and this 3 factorial divided by 2 factorial, that will be 3, and this will be 1. Total answer is what? What is total answer? That will be 4. So how many 4 pennants you can create? So the number of 4 pennants, that will be equal to 4. So very simple. You can create total 4 pennants. You can 4 pennants you can create. So remember, number of 4 pennants. What is that? That is equal to 4. And which are these 4 pennants? For example, you can create this 4 pennant. You can use 1, 2. Okay, you can create this. You can create this. You can create this, and also you can create 2, 2. So you can easily notice. Sorry, total how many? 5. Okay, summation equal to 5. Sorry, 3 plus 2, that is equal to 5. So total how many 4 pennants you can create? That will be 5. Total 4 pennants we can create. Okay, so very simple. Is this point clear? This is method number 1. Okay, very simple. Method number 1 is very simple, right? So tell me, if I ask you how many 10 pennants you can create, the question is asking 10 pennants. How many 10 pennants you can create? This is the question. So tell me, how will you do? Okay, what you can do? You can use your method number 1. Again, very simple method. Okay, just create cases, nothing else. Very simple method. What you can do? You want to find 10 pennants. 10 pennants means summation equal to 10. Sequence of 1, 2. Okay, remember 10 pennant means sequence of 1, 2 with summation 10. Okay, the summation should be equal to 10. So what you can do? You can create cases. You can decide how many 2's you are going to use. Okay, so what you can decide? You can decide how many 2's you are going to use. So what you can do? You can create case 1. In case 1, you are using no 2. Okay, you are using no 2. If you are using no 2, it simply means all the ones you are using. It simply means you are using all the ones. Okay, 5, 1, 2, 3, 4, 5. Okay, so you are using all the ones. Is this point clear? So if you are using no 2, okay, in the case number 1, I am not going to use 2. This 2 I am not going to use. Means sequence of 1. Sequence of 1. Summation should be equal to 10. Summation should be equal to 10. Okay, this is summation. This summation should be equal to 10. So how many ways are there? Means how many 10 pennants you can create in this way? In this way, how many 10 pennants you can create? Only 1. Okay, this is the only 1 10 pennant you can create. You are using all the ones. Okay, so you can only, this is only 1. Okay, in this case. What about case 2? Tell me, what about case 2? You are going to use 1, 2. You are going to use 1, 2. Means you are going to use 1, 2. It simply means how many ones you will use. If you use 1, 2, then how many ones you need to use? Total 8, right? Total 8. So very simple. Now any permutation, because order matters. Agree? You can create any permutation. Remember, in a sequence, order matters. So you can create any permutation. Every permutation will be a pennant. Every permutation will be a 10 pennant. So how many permutations are there? Here you can notice these are same. It's like 8 times A and 1 time B. This is like this. 8 times A. It's like 8 times A, then A, and then B. So how many permutations are there? Tell me. What is the number of permutations here? So the number of permutations will be 9 factorial divided by 8 factorial. Agree? Very simple. Total 9 factorial. How many permutations are there? That will be 9 factorial divided by 8 factorial. So very simple. The same thing here. Any permutation you can create. So it will be 9 factorial divided by 8 factorial. That is equal to 9. Okay. What is the case number 3? What is the case number 3? You can use 2 2's. If you are using 2 2's, how many ones you need to use? Remember, the summation should be equal to 10. So if you are using 2 2's, then how many ones you are going to use? A total 6 ones. 6 ones and 2 2's. Now any permutation here, you can create any permutation because order matters. Okay, in a sequence, order matters. In the pennant, when you create the pennant, then order matters. So tell me how many? Like for example, if you have 6 A's and 2 B's, so how many permutations are there? What are the number of permutations? Tell me. Tell me the answer. That will be total how many? Total you have 8 factorial divided by 6 factorial 2 factorial divided by 6 factorial 2 factorial. Okay, very simple. Yes or no? Because these are 6. You have 6 A's, you have 6 A's and you have 2 B's. So very simple. Total will be 8 factorial divided by 6 factorial 2 factorial. This will be your answer in this case. So in this case, you will have 8 factorial divided by 6 factorial 2 factorial. You can check it out, whatever this value is. Can you tell me? Can anyone tell me what is this value? So you can see it will be 8 into 7 divided by 2. So I think it will be 24. You can check it out. Okay. Next, what is the case number 4? Tell me, what is the case number 4? In case number 4, you can use 3 twos, right? You can use total 3 twos. So total 3 twos you can use. If you are using 3 twos, then how many ones you are using? Tell me. Number of 10 pennants we want. So tell me how many ones you are using. If you are using 3 twos, it simply means you are using 4 ones and 3 twos. Okay, 4 ones, 3 twos. Now in this situation, your answer will be what? That will be 7 factorial divided by 4 factorial 3 factorial. So it will be 7 factorial divided by 4 factorial 3 factorial. Next, what is the case number 5? What is the case number 5? That is, you are using 4 twos. You are using 4 twos. If you are using 4 twos, then how many ones you are using? You are using 4 twos. So it means only 2 ones you are using. Now the answer will be what? Any permutation. You create any permutation here. So how many 10 pennants you can create where you are using 4 twos? So that will be your 6 factorial divided by 2 factorial 4 factorial. So it will be 6 factorial divided by 2 factorial 4 factorial. And finally, what the case number 6? The case number 6 is you are using all the 5 twos. You are using all the 5 twos. So that will be like 2, 2, 2, 2, 2. You are using all the 5 twos. If you are using all the 5 twos, then there is only one way, or you can do like this: 5 factorial divided by 5 factorial. See, either you can say only one, because only one way, all twos you are using, all twos. So, or what you can do, you can create any permutation. Any permutation means 5 factorial divided by, because all are same, so 5 factorial divided by 5 factorial. Anyway, you will get 1. So you calculate this one. What will be this? Please tell me here what will be the answer. I think it will be 35. Okay, it will be 35. And what will be the answer here? So this will be, I think it will be 15. Now you tell me the total. What is the total number of 10 pennants that we got? So what is the total number of 10 pennants? So the number of 10 pennants, what we got, that you can just add all of them. 1 plus 9 plus 24, 1 plus 9 plus 24 plus 35 plus 15 plus 1 plus 35 plus 15 plus 1. Okay, you can check. What is this value? Can anyone tell me? Okay, you just calculate this value, you will get your answer. Okay, very simple, isn't it? So this is your method number 1. We have seen method number 1 only. This is the method number 1 for solving this question. Did you understand this? Please tell me. Did you understand this method? Okay, is there any mistake here? So in the calculation, here you will get 8 into 7. Yeah, that will be 28. Okay, so this will not be 24, this will be 28. So if this is 28, then it will be 28. Okay, you can add all of them. What will be the answer? Is the answer 85? 85 or 89? Tell me. What is the answer? You can check it. Okay, you can do the summation. That will be your answer. 89. Very good. Okay, so tell me here. Did you understand this one? This question, did you understand? This method, did you understand? Method number 1. We have seen the method number 1 to solve this question. Okay. Now, let's see method number 2 also. So, if you understood the method number 1, then let's see method number 2 also. What is that? That is more interesting. That is, can you create recurrence relation for n-pennant? See, very simple. Can you create a recurrence relation for n-pennant? We know what is n-pennant. If I want to create n-pennant, then what I need? I want to create n-pennant, then this is nothing but a sequence. It is a sequence of 1 comma 2, right? It is a sequence of 1 comma 2 with summation equal to n. The summation should be equal to n. Okay, with the summation equal to n. So, and in this order matters, right? This is already given in the question, that order matters. In which order you do, that matters. Okay, so can you create a recurrence relation for this? Now this is our method number 2. Our method number 2 for solving this question, what is that? That is, can you create a recurrence relation? Okay, let's create a recurrence relation for this. You tell me one thing. Here order matters, right? So what I put on the first position, that matters or not? Tell me. Simple question I am asking. What I put in the first position, that matters or not? For example, order matters. Order matters. So what I put in the first position, that matters, correct? Okay. In the first position, what are the choices? What are the choices? I want to create a recurrence relation for n-pennant. N-pennant means this is a sequence of 1 comma 2. I can only use 1 comma 2. And the summation should be equal to n. The summation must be equal to n. Okay. So the summation should be equal to n. And the order matters. So what I put here, that matters, correct? For example, if I put 1 here, can I say that will be different if I put 2 here? If I put 1 here, can I say, because order matters? Okay, so very simple. Here I can say this and this, they are different. This and this, they are different, right? So either you can put 1 here or you can put 2 here. Only 2 choices you have. Either you can do this or you can do this. There is no other choice because we can only use 1 comma 2. Now you tell me, I want how many n-pennants I can create. So let's assume number of n-pennants is equal to fn. So let's assume number of n-pennants. I'm saying that number of. So let's assume number of n-pennants, and that is equal to f of n. Let's assume, okay, that is number of n-pennants. So you tell me, if I want to create n-pennants, just focus on n-pennants. If I want to create n-pennants, then there are 2 ways. What I can do, either I can start with 1. I can start with 1, or what I can do, I can start with 2. Either I can start with 1 or I can start with 2. Now, if I am starting with 1, in this case, how many n-pennants are there? If I am starting with 1, this is fixed. This is fixed. I am starting with 1. Okay, in this case, how many n-pennants are there? In this case, so if I am starting with 1, I want the summation equal to n. The total summation should be equal to n. So tell me what summation I want here. What summation I want here? I want n minus 1. Very simple. Agree or not? See, the total summation I want, this total summation should be equal to n. Now, if I start with 1, then here I want n minus 1, correct? So what I want, here I want n minus 1 pennant. So here I want n minus 1 pennant, n minus 1 pennant. Okay, so I can say number of n pennants, that will be equal to number of n minus 1 pennants. Okay, when you start with 1, then you can count number of n minus 1 pennants, plus, or there is or here. Okay, there is or here. So plus, you can start with 2. If you start with 2, then what I want, tell me. If you start with 2, then what I want here, I want n minus 2 pennant. I want n minus 2 pennant, because if I'm starting with 2, then the summation I want equal to n minus 2. I want summation equal to n minus 2. So what I can do, I can say number of n pennants, that is equal to, if I start with 2, then I can count number of n minus 2 pennant. Okay, if I'm starting with 2, already this is fixed. This is fixed. I am starting with 2. If I'm starting with 2, then I can count number of n minus 2 pennants. And if I'm starting with 1, I can count number of n minus 1 pennants. Okay, so very simple point. Very simple. Remember, if I start with 2, I can count number of n minus 2 pennants. If I start with 1, I can count number of n minus 1 pennants. Either I can do this or I can do this. And these are mutually exclusive. These are mutually exclusive, because here I am starting with 1, here I am starting with 2. So they are different. So this case and this case, they are mutually exclusive. So finally, my answer will be what? How many n pennants I can create? That will be equal to fn minus 1 plus fn minus 2. So very simple. The number of n pennants, that will be number of n minus 1 pennants plus number of n minus 2 pennants. This will be the recurrence relation. Okay, this is going to be the recurrence relation. And what are the base conditions? What are the initial conditions? Tell me. If I ask you what is f1, f1 means number of 1 pennants. How many? Number of one pennants. So how many? If I want number of one pennants, then that will be only one. Okay, because what you can do, you can just simply do like this. This is the only. Okay, so that will be one. Okay, and that is your, this is the only one pennant you can create. How many two pennants you can create? Number of two pennants. Tell me how many two pennants I can create. See, if I want to create two pennants, either I can do this, I can either do this, or what I can do, I can do this. So number of two pennants, that will be two. That will be true. These are the initial conditions. So I got initial conditions, I got recurrence relation. Now I can find anything. I know what is F1. Okay, I know what is F1. F1, that is equal to 1. What is F2? F2 is equal to 2. Okay, and I have this recurrence relation that Fn is equal to Fn minus 1 plus Fn minus 2. So tell me what will be F3? Tell me what will be F3? F3 will be equal to F1, F2 plus F1. F3 will be F2 plus F1. So what will be F3? F3 will be F2 plus F1. F2 plus F1. That will be 3. What will be F4? F4 will be F3 plus F2. So that will be 5. And what will be F5? F5 will be F4 plus F3. That will be 8. Okay, and what will be F6? For example, what will be F6? Remember, F6, that is equal to F5 plus F4. If I put n equal to 6, then I will get F6 equal to F5 plus F4. So that will be F5 plus F4. What is F5? That is 8. What is F4? That is 5. So that will be 13. So remember, F6, that will be 13. Similarly, I can find F7. That will be what? 13 plus 8. That will be 21. Okay, what about F8? Can you tell me what about F8? F8 will be summation of these two. That will be 34. What will be F9? F9 will be summation of this and this. What that will be? That will be 55. And finally, what is F10? F10 is summation of 55 plus 34. So that will be 89. So your final answer will be 89. Is this clear? This is your final answer. So we have seen two methods. Method number 1, method number 2. Tell me, which is your favorite method? Which method did you like? See, for this question, how to find n pennants, how to find 10 pennants, how to find 10 pennants. We have seen total two methods we have seen. We have seen method number 1 and we have seen method number 2. We have seen using recurrence relation also. Method number 2 means using recurrence relation. In this method number 2, we are creating the recurrence relation. And this recurrence relation, we are creating that number of n pennants is equal to number of n minus 1 pennants plus number of n minus 2 pennants. Okay, because number of n pennants, that is equal to, if you start with 1, then you can count number of n minus 1 pennants. If you start with 2, then you can count number of n minus 2 pennants. So this is the method number 2. This is the recurrence relation method. Recurrence relation method. Okay, and what is method number 1? That is your by case method. In this, you are creating the cases. You are creating the cases means how many twos you are taking. Okay, you can take 0, 2, you can take 1, 2, 2, 2, 3, 2, and so on. So two methods we have seen to solve this question. Tell me, did you understand both of them? I want to ask you, did you understand both the methods? This method also, this method also. Did you understand both of them? Second point, which method did you like more? Which method did you like more? You can tell me. Okay. So anyway, this is your question. This is your GATE 2014 question. You can see GATE 2014 question. Very nice question. Now I can tell you one thing, that the question maker of this question, okay, the professor who has created this question, what do you think? Which method he is thinking? The professor who created this question, what method this professor is thinking that students will be using? Tell me, like this professor will be having which method in mind? Method 1 or method 2? I think method 2. Okay, because this is more, I can say, more analytical method. This method number 2, this is more analytical method. This is more, I can say, more sophisticated. Okay, method number 2, this is more sophisticated method. So anyway, but you have method number 1 also, you have method number 2 also. You can use any of them. But the most important point is not getting the answer. That is understanding the method. You understand this also, you understand this also. What many students do? Many students, what they will do? they will understand this method, they will get the answer, and they will not try to understand this. Okay, I have seen this. Okay, many students, what they will say, yes, I got this method I understood, I got my answer. Now they will not care about this method, they will not try to understand this method. But you should understand everything. Okay, you should understand every method, everything you should understand. In the GATE exam, you can apply any method that you want. You can use this method or you can use this method. That is your choice. But understand everything.